This is a video about correct material selection for spray nozzle systems. Now, the first thing to note in this discussion is that nozzles are quite delicate components. So they generally have quite small orifices, and any small defects, any small amounts of wear or corrosion can have actually quite big effects on the performance of the nozzle. And as the nozzle is the last bit of the system that's in contact with the fluid, that can have a big effect on the overall performance of the whole system. So if we're looking at a gas scrubbing system, where corrosion in the nozzle can have a very big effect on the effectiveness of the entire system. It's very, very important that we get material selection correct to reduce those defects and those problems within the system. It's also important to note that all nozzles are naturally a wear part. They're going to wear out eventually because the very motion of fluid coming through a nozzle at pressure, which is basically what they do, is going to cause wear eventually. And so we need to ensure that those nozzles are able to be maintained, able to be removed for inspection and to check for the damage and corrosion and wear, and to be replaced if necessary. They're all going to wear eventually. So what sort of things come into consideration when we're actually looking at material selection for nozzles? Well, the first one is heat. How hot is this environment? Often nozzles are spraying in very hot environments, and that can have a big impact on the type of material we want to make the nozzle out of. Again, to go back to a previous point, we need to understand that nozzles are quite sensitive to heat, and the very fact that they are spraying a liquid in a potentially hot environment means that they're even more sensitive to temperature than perhaps other components in a dry heat. Hot, wet environments are inherently more damaging than hot, dry environments, and nozzles are always going to be, by their very nature, in a hot, wet environment because they're spraying liquids. So when we're looking at the temperature ratings for certain nozzles, the fact that they're quite delicate, they're quite precision components with small orifices in that are susceptible to damage even with small deformations, and they're spraying in a wet environment by their very nature, means that the temperature ratings for spray nozzles based on their material are actually often quite a lot lower than we would expect for other components made from the exact same material. For example, our spray nozzles made of 316 stainless are only rated to 430 degrees. Now, other stainless steel components made of the exact same material will be rated to much higher temperatures than that, but for spray nozzles it is only 430 degrees. This chart you can see here has a temperature rating for each of our spray nozzles, and what you'll note from that is that they're actually quite low. This is because by nature they're going to be in a wet environment, and by their nature they're quite delicate components. When considering what materials to make nozzles out, we need to look at the temperature of the environment, look at the temperature chart, and then make an appropriate selection there. The next factor to consider is chemical corrosion. Often our spray nozzles are spraying either corrosive materials or they're in a corrosive environment, and they're going to be susceptible to chemical attack. Now, plastics, especially plastics like PVDF and PTFE, have excellent chemical corrosion for a wide variety of different chemicals. They're absolutely superb for those. But plastics don't like heat too much, so we've got some severe restrictions on when we can use plastics depending on the temperature of the environment. Stainless steels are good for chemical corrosion. They'll handle a lot of caustics and corrosive materials, but will struggle with some corrosives, especially at higher temperatures. Now, we've got to remember that it's not just a question of looking at the chemical compatibility on the material and the chemical in question alone. We need to look at it at the right temperature. So temperature comes into play, and often corrosives at higher temperatures are going to attack materials a lot quicker than they would at lower temperatures. So we need to factor that in as well. So stainless steels are good, but again, they may struggle with some corrosives, and especially at high temperature corrosives. So then we may need to look at things like Hastelloys and other more advanced steels, and maybe even look at more exotic alloys as well. And these can get very expensive, but they may well be necessary. We need to consider also the worst case scenario when looking at corrosion. So what's the highest temperature it could be at, and what's the highest concentration of the corrosive that we could expect. The final consideration when looking at material selection for spray nozzles is to look at abrasion and wear. Now, as we mentioned before, nozzles are a natural wear part, but abrasion and wear is different from chemical corrosion. This is the actual physical wearing down of the part, either by the motion of the liquid through the spray nozzle, or in many cases, particularly in things like gas scrubbing, the actual environment itself may contain particulates that are moving around quite quickly that the nozzle sat in, and this can cause external wear on the nozzle. What types of material are good for abrasion? Well, plastics, again, despite being excellent for chemical resistance, they're not so good for abrasion resistance because they're soft, they get worn away quite quickly, so that may preclude plastics from many environments. Metals are better, brass isn't particularly good, it's quite soft, stainless steel is better than brass, but then even that may not be suitable for many environments, particularly if we're spraying at high pressures, which cause more wear, or we've got particularly abrasive, nasty environments that we're spraying into. And then we may need to look at things like tungsten carbide, which is highly wear resistant, or even more advanced alloys than that, or things like really hard ceramics, or even things like ruby orifice nozzles for really high pressure spraying, precisely because of their much harder and therefore much more wear resistance. Now obviously the cost of these nozzles goes up as we get more and more abrasion resistant materials, but that cost is offset by the cost of maintenance. With lower abrasion resistant materials, we're going to have to be removing and maintaining those nozzles and replacing those nozzles far more often. And in things like gas scrubbers, it's not so much the cost of actually replacing the nozzle that's the problem. The cost is associated with actually shutting down that gas scrubber and having downtime, because it's very difficult to maintain them whilst they're on. Often the more expensive, highly abrasion resistant materials like advanced ceramics and tungsten carbide are well worth spending the extra money on when you factor in the additional maintenance cost of using softer materials. Those are the three core factors that affect material selection in spray nozzles. I hope you found this video useful, and if you have any further questions on any aspects of spray nozzles and spray technology, then please call the Spray Nozzle people. This is what we do. We consult with engineering companies all around the world on all aspects of spray and spray technology.